Hello, I'm Brian Farrell, and welcome to PACE IT's session on random access memory. Today we're going to be introducing RAM, we're going to talk about different types of dynamic RAM, and then we will cover some special considerations of random access memory. And with that, let's go ahead and begin today's session. And of course, I'm going to begin by introducing RAM. When most people talk about computer memory, they're talking about dynamic random access memory, DRAM, not the St. Louis RAM. DRAM is not the only type of memory that is present, but it is the one that most people are familiar with. DRAM is used to hold data and pass it between the CPU and storage devices. We use dynamic random access memory because it's quicker and more responsive than using the storage device itself, and it can hold a lot more data than the CPU. We commonly refer to dynamic random access memory as RAM, random access memory. So how does RAM work? Well, it uses transistors and capacitors to hold electrical charges. Arrays of these transistors, called registers, the registers are either on or off. That's the binary 1 or 0. If there is no electricity, there is no memory. Now there are two basic types of RAM. And the first type is static RAM, SRAM. Static RAM is located on the CPU die or just off of it. It's commonly referred to as cache or cache memory. It's super fast, but it's also very expensive, so it's used in limited amounts. Dynamic RAM, on the other hand, is always located off the die. It's fast, but not as fast as static RAM. But it's also relatively inexpensive, so we can use a whole lot more of it. Now let's talk about types of dynamic RAM. And we begin with the dual inline memory module, the DIMM. Now the DIMM is both obsolete and cutting edge. Before the introduction of the DIMM, memory modules could only receive current through one side of their electrical contacts. This limited the memory bus to only being 32 bits wide. The DIMM could receive electrical current through both sides of the electrical contact, and the memory bus grew to 64 bits wide. All current RAM are types of DIMM. So now let's move on to synchronous dynamic RAM, SDRAM. This is the true beginnings of modern RAM. It was the industry standard beginning in 1993. It was synchronized with the system clock and could perform an operation with every cycle of the clock. It's currently considered obsolete. Why? Well, because it was replaced by DDR. Now, DDR was introduced in 1996, and it effectively doubled the possible rate of data transfer by taking advantage of the falling and rising edge of the clock cycle. That means that it could perform 2 operations per cycle. The speed of the RAM is determined by a specific formula. It's the clock rate times 2 times 64 divided by 8, and that gets you your megabyte transfer rate. Now, if Intel had had their way, DDR RAM would have been replaced by Rambus, dynamic random access memory. Now, Rambus was a proprietary standard developed by Rambus Inc. that was initially supported heavily by Intel. It had to be installed in pairs, or you had to use a special device called a continuity module, also called a RIM, in order for it to function. It was faster than DDR, but it was not as cost-effective as DDR, so it never really caught on. Now let's talk about DDR2 and DDR3. DDR2 doubled DDR's performance. The formula to figure out its transfer rate is clock rate times 4 times 64 divided by 8. That was superseded by DDR3, which doubled DDR2's performance and is the current standard. Its formula is clock rate times 8 times 64 divided by 8. Super fast. Soon we're going to see DDR4 and DDR5 being common, but not quite yet. Then there's small outline dual inline memory modules, SODIMM. This is compact memory modules that are used in small form factor computers, like laptops in most cases, and in tablets. Now, SODIMM can be DDR, DDR2, or DDR3, all depending upon the manufacturer. There's also parity and non-parity RAM. Parity RAM modules have an extra bit, a parity bit, that is used to check for errors in RAM. It can't fix the errors, but they can find it. It's more expensive than non-parity RAM, and it's not really needed anymore because applications check for errors now. Then there's error correcting code RAM, ECC RAM. ECC RAM can detect and recover from errors in memory. It's much more expensive than standard RAM, but it should be used in situations where an error can't be tolerated. Now there's another thing to consider about RAM. It can be dual-sided or it can be single-sided. Dual-sided RAM is when the memory modules on a stick are separated into ranks. Only one rank may be accessed at a time. Single-sided RAM, on the other side, is when memory modules are not separated into ranks. It is faster, but more expensive than dual-sided RAM. Now let's move on to some special considerations of RAM. This first consideration is single-channel versus multi-channel RAM. In single-channel RAM, all banks or slots of the RAM make up a single 64-bit bus to the CPU. In multi-channel RAM, the banks of RAM may be grouped together to form a wider bus to the CPU, and that bus may be 128 bits or 192 bits wide. To take advantage of the multi-channel abilities of the RAM must be installed in matched sets. And you need to follow the motherboard documentation when installing multi-channel RAM. You also need to know what type of RAM your motherboard supports. A motherboard will only support one type of RAM. You can't mix different types together. The RAM modules are keyed on the bottom so that they can't be placed into the wrong type of RAM slot. And the final thing that you need to consider, you can install different speeds of RAM together, but you need to remember that the RAM will only function at the speed of the slowest module. Now that concludes this session on random access memory. We talked about RAM, we talked about different types of RAM, and then some special considerations about RAM. Now on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon.